Hello there. This is we're going to talk about section 4.1, which is figuring out how we figured out what the atom looks like. I mean, it's so small. How are you going to know what's inside the atom and the parts of it? So in science, we always do experiments, and so this lab tech is looking at a petri dish, figuring out the bacteria living on it, and so she's using magnification. In chemistry, we can magnify things, but sometimes we can't see everything. So we have to use experiments and decide what we can figure out kind of indirectly, because we can't see the insides of the atom. So we have to use experiments to make a good theory guess about it, a hypothesis about what the parts of the atom are. So we've done lots and lots of experiments to figure that out. So at the very beginning of time, people have always been thinking about what everything's made out of. It's the mystery of our time. And so we now know that the atom is the smallest particle that has all the identifying characteristics of an element, and it retains its identity in a chemical reaction. So atom is the smallest part, but still keeps all of the characteristics of the element in it. So people have been thinking about this for a long time. So Democritus, way back in the Greek days, and he came up with the idea that everything is made from atoms, and atoms, you can't break them down, you can't destroy them. Part of that's true, but we can get to the parts of the atom, so we can't destroy them. But he wasn't able to do experiments because that was way back in the day. So he just came up with a theory, and he wasn't able to prove it with experiments. John Dalton, on the other hand, took this idea further, and he was able to do experiments. And he came up with a theory, and it was called Dalton's atomic theory. It had a lot of good ideas in it. We've changed a little bit of it, but this is really good. The first part, he says, is everything is made of atoms, and they're very small, and you can't divide them up. Atoms of the same element are identical. That's what his theory said. Now we know that's not quite true. And atoms of one element are different from those of another element, and that's true. Atoms can be physically mixed together, or can be chemically combined in a whole number of ratios, like H2O. This is a really revolutionary new idea, and he came up with it. And when we have a chemical reaction, atoms are either joined up with another element, or separated if they're already in a combination, or rearranged. So that's what a chemical reaction is. We're putting atoms together, or we're separating two atoms apart, or rearranging things. So what instruments can we use to look at individual atoms? They're really, really small, but we can use some instruments, like a scanning tunneling microscope. And I used to work with a chemist who did this when I worked at Dow Chemical, so that was pretty exciting. So this one is actually seeing parts of the atom through the microscope. So let's see what you remember from this section. Who was the Greek who decided on atoms? You're right, it was Democritus. Good job. So this Dalton's theory improved what Democritus thought by saying what? So Dalton was able to use experiments to come up with a better theory. Lastly, how can we see atoms? Right, scanning tunneling microscope, like the friend I had at Dow Chemical. It's good talking to you, and we'll continue on with the atom soon. Talk to you later. Bye-bye.